Greetings. Welcome to W1U3 review of revised Bloom's taxonomy of learning. We have covered the Bloom's taxonomy of learning, its revision, and its cognitive process hierarchies, knowledge categories, all these things in our earlier courses on TALE, NATE, even the presently running course, outcome based education and accreditation. In this unit, we will go through a brief review of the revised Bloom's taxonomy, the assumption being that the listeners are all familiar with the Bloom's taxonomy from one of the earlier courses. So, it is a quick review of the revised Bloom's taxonomy. So, the outcome of this unit is recall important features of revised Bloom's taxonomy, and we are going to consider only cognitive domain. So, the outcome is recall important features of revised Bloom's taxonomy of cognitive domain. As I just now mentioned, we have covered this taxonomy in great detail in earlier courses. So, this is a review, so the outcome is only a recall. So, what are learning outcomes? These are what the learners are expected to do at the end of a unit of learning. The unit of learning can be a program, a course, or an instructional unit. At the end of that, what the student is able to do, what the learner is expected to do, that is the learning outcome. For this purpose, it is desirable to have a taxonomy that is applicable to learning outcomes, assessment, as well as instruction. All the three aspects of the unit of learning, that is, the outcomes, assessment, and the teaching or instruction. There are several taxonomies like Bloom, Solo, Fink, Gagne, Marzano, and Kandal, etc. And people have experimented with all these different technologies and taxonomies over the years and tried to come out with the effectiveness and the engaging capability of all these taxonomies. All these taxonomies are attempts to give a structure to the cognitive processes involved in learning. Reverse Bloom's taxonomy of cognitive domain is the most popularly used taxonomy across the world. And we will be following this revised Bloom's taxonomy of cognitive domain in all our further discussions. The original proposal of Bloom, the original Bloom's taxonomy, suggested three learning domains. Any given task tend to be generally dominant in one of these three domains. According to the original Bloom's taxonomy, the three domains of learning are cognitive, affective, and psychomotor. So, any given task tends to be dominant in one of these domains, though all the three domains are in general involved in any given task. The cognitive domain deals with a person's ability to process and utilize information in a meaningful way. The affective domain relates to the attitudes and feelings that result from or influence the learning process. The psychomotor domain involves manipulative or physical skills. This classification, as we just now noted, is for focus and convenience. All the three domains are involved to varying degrees in all intended learning experiences and activities. The original Bloom's taxonomy had only one dimension, but the revised Bloom's taxonomy is two-dimensional. Along one dimension, the cognitive processes are listed, and along the other dimension, the knowledge categories are listed. So, it is a two-dimensional taxonomy. What are the cognitive processes of revised taxonomy? At the lowest level, it is remember. At the next level, we have understand, then apply, analyze, then evaluate, and finally create. They are hierarchically organized in the sense that any process at a given level implies all the processes at all the lower levels. For example, analyze implies the ability to apply, understand, as well as remember. Very briefly, we look at these six cognitive process levels. Remember, this act of remembering is retrieving relevant knowledge from long term memory. The relevant knowledge may be factual, conceptual, procedural, or some combination of all these three. Remembering knowledge is essential for meaningful learning and problem solving. Though is at the lowest level, it is important that the learner is able to remember because this is fundamental to meaningful learning and problem solving. There are two sub processes under remember. One is recognizing, another is recalling. And we already discussed what is the difference between these two. The associated action verbs are recognize, recall, list, tell, locate, write, find, mention, state, draw, label, define, name. We can have any number of these things, but all these are involved with only the action of retrieving the information, either uh, recognizing the fact or information from a presented list or recalling it based on a keyword from the long term storage. Understanding is constructing meaning from instructional messages. Now, these instructional messages can be verbal, pictorial, graphic, or symbolic. These are received during the learning activities. That means they could be received during the lectures, demonstrations, field trips, performances, or simulations, and they might be received from written sources, printed sources like books, or may be seen on a system, so from computer monitors. So, from these instructional messages, the understanding constructs meaning. That is this cognitive process. The sub processes associated with understand and the action verbs which are relevant to that sub process are interpreting, which means either translate, paraphrase, represent, or clarify, exemplifying to give an instance of that category, that means instantiate, or it can be illustrate. Classifying is the other way, categorize or subsume. A given instance is categorized into one of the classes. Summarizing, which is generalize or abstract. Inferring, find a pattern, extrapolate, predict. Comparing two or more of the given elements, either the action verbs are contrast, match, distinguish, differentiate, etc. Explaining, construct a model, explain. These are the action verbs typically associated with the sub processes under the category of understand. Apply, this is the next higher level cognitive process. Use procedures to perform exercises or solve problems. This is closely linked with procedural knowledge. The sub-processes are execute and implement. Execute is to solve a task for which the right procedure is already known. This produces a very clear, unique solution, and this involves routinely carrying out the procedure clearly indicated in the problem or the context. And the context itself is a familiar context, which means that execute is concerned with a routine application. So the procedure is known, the context is known, and it is familiar. And on the other hand, implement solves a problem that has features which have not been encountered in that form earlier. So, certain amount of novelty exists. Students need to select a procedure or they may have to even modify it to solve the task. It may be necessary to use other cognitive processes like understand in order to be able to solve the problem. This is categorization is not a kind of binary in the sense that you have just execute or implement. It is a spectrum. It is a spectrum of abilities starting at the lowest level with execute and at the highest level with implement. Within apply, we have a spectrum of abilities. Okay. Action verbs associated are execute, implement, determine, calculate, compute, estimate, solve, draw, modify, etc. The next process is analyze. It involves breaking given material into its constituent parts and determining how the parts are related to one another and to an overall structure. The sub-processes are differentiate, distinguish relevant parts or important parts from unimportant parts or irrelevant parts of the presented material. The associated verbs can be discriminate, select, focus, distinguish, etc. Another sub-process is organize. Build systematic and coherent connections among the pieces presented, pieces of presented information. The verbs are structure, integrate, find coherence, outline, parse, etc. The next one is attribute. Though this sub-process occurs very rarely in engineering activities, it is a sub-process of analyze. The attribute is to determine a point of view, a bias, values, or intent underlying the presented material. Deconstruct is a verb. As we just now observed, the use of the word analyze in engineering has always been tricky. It's used quite extensively, but its use is not all that clear or unambiguous in all cases. In several contexts, the word analyze actually is used in engineering to mean apply. So, analyze in the sense that it is used in the revised Bloom's taxonomy occurs relatively rarely in engineering, and assessing that ability is rather difficult. It's not that easy to design questions in this category which can be answered in limited time written examinations. Often, analyze activities are included in assignments related to case studies, projects, term papers, and field studies. The next process is evaluate. Make judgments based on criteria and standards. Making judgments is done by all the people all the time, all learners all the time. But this is making judgments based on criteria and standards. That is the important aspect of this criteria and standards. Criteria can be related to quality, effectiveness, efficiency, and or consistency. The standards may be either quantitative or qualitative. Even qualitative standards are accepted. The sub processes are check and critique. Check is judgment about consistency. So the verbs can be test, detect, monitor, coordinate, etc. Critique, judgment based on criteria and standards. It can be judge what is judged, accuracy, adequacy, appropriateness, clarity, cohesiveness, completeness, correctness, reasonableness, reliability, validity. Like this, these can be judged. The next level, the highest level within the cognitive processes hierarchy of Revised-Bloom's taxonomy is create. It involves putting elements together to form a coherent or functional whole. These sub-processes are generate. This is a divergent phase where multiple representations, alternative solutions are explored. The alternative hypothesis may be developed, theories and explanations may be explored. So, this is a divergent phase. Then plan, start of the convergent phase, often implicitly carried out, devising a plan for solving the problem. So, the associated verbs are plan, design. Then the other sub process is produce, carrying out the plan for solving the given problem. The verbs can be construct, produce. These last four, that is apply at the sub process level of implement rather than execute. So, apply at implement level, then analyze, evaluate and create are generally called as higher orders of learning or deep learning or meaningful learning. So, these are generally considered as important in the learning activities, and the instruction must be designed in such a way that it addresses these higher orders of learning. People have been using different kinds of words to mean this, but essentially what is important is that the instruction must address these higher orders of learning. Then the other dimension of the revised Bloom's taxonomy is categories of knowledge. We have four general categories which are there in the revised Bloom's taxonomy, that is factual, conceptual, procedural, metacognitive. Then there are four more categories specific to engineering, and these have been derived as mentioned in earlier courses from Vincenti. The categories specific to engineering are fundamental design principles, criteria and specifications, practical constraints, design instrumentalities. Factual knowledge are the basic elements students must know if they are to be acquainted with the discipline or solve any of the problems in it. It exists at a relatively low level of abstraction. The subtypes of factual knowledge are knowledge of terminology, example words, numerals, signs, pictures, and knowledge of specific details, including descriptive and prescriptive data and the elements. The next level is conceptual knowledge. Now, what is a concept? It's not all that easy to define the concept of a concept, but in a broadly understanding way, we can say a concept denotes all the entities, phenomena, and their relations in a given category or class by using definitions. Concepts are also the basic elements of propositions, much the same way a word is the basic semantic element of a sentence. It includes knowledge of categories and classifications and the relationships between and among them. These include schemas, mental models, are implicit or explicit theories. Both factual knowledge and conceptual knowledge deal with what. Procedural knowledge deals with how. So it is the knowledge of how to do something. It often takes the form of a series or sequence of steps to be followed. So the steps could involve decision making and branches, but primarily the procedural knowledge consists of a sequence of steps. It includes knowledge of skills, algorithms, techniques, and methods, collectively known as procedures. It also includes knowledge of the criteria used to determine when to use which procedure. If there are multiple procedures possible to solve a given problem, how does one select one among the available procedures? So, the criteria used to determine which one to be used to solve a given problem in a given context is also a part of the procedural knowledge. And procedural knowledge is specific or germane to the subject matter or academic discipline. The next important one is the metacognition. Now, in the time period since the introduction of Bloom's taxonomy, the importance of metacognition has been recognized by all the teaching fraternity and all the researchers in the education domain, and it is becoming increasingly clear that metacognition is an extremely important knowledge category that all teachers should be aware of. Metacognition is thinking about one's own thinking. It is the ability to assess our own skills, knowledge, or learning. A person's awareness of his or her own level of understanding, knowledge, and thought processes. This is how Stephen Chu tries to explain this metacognition. Metacognitive ability affects how well and how long a student studies, how much and how deeply students learn. So, the metacognitive ability is knowledge about cognition in general, as well as awareness of and knowledge about one's own cognition. Why we should be concerned with metacognitive? As I mentioned, the importance of metacognitive abilities has been increasing over the period of time in all the learning theories. High performing students generally tend to have better metacognitive skills, and weaker students typically have poor metacognition, besides many other weaknesses. Poor metacognition is a big part of incompetence. Students with poor metacognition skills will often shorten their study time prematurely, thinking that they have mastered the course material that they barely know. They are grossly overconfident in their level of understanding, underestimate or overestimate their performance in tests. Many teachers would have encountered these kind of scenarios many times during their classroom experiences. And the students with poor metacognition skills make, in general, poor study decisions. What are the elements of metacognitive knowledge? Assessing the task at hand, evaluating one's own strengths and weaknesses, planning an appropriate approach, applying strategies and monitoring performance, reflecting and adjusting one's own approach, beliefs about intelligence and learning. There are many other elements, but these are the most important elements of metacognitive knowledge. These four categories are categories which are general to all areas of study. Then categories of knowledge which are specific to engineering are listed below. Fundamental design concepts, criteria and specifications, Practical constraints, design instrumentalities. Fundamental design concepts relate to things like operational principles of devices and components within a device. These basic concepts are used in all engineering designs. Examples can be a device can perform variety of tasks by incorporating memory into it. A device that has two well-defined states can be used as a memory unit. Stepping movement can be created through interaction between two salient magnetic fields. An airfoil, by virtue of its shape, in particular its sharp trailing edge, generates lift when inclined at an angle to the airstream. The next category is criteria and specifications. It is necessary to translate the qualitative goals for the device into specific quantitative goals. As we discussed in earlier courses, this aspect is not given adequate importance in most of the engineering courses. Most of the time, the instruction does not give adequate importance to criteria and specifications. Examples of uh, criteria and specifications include any power converter should have efficiency above 95%. The speed control unit for the DC motor should not create harmonic distortion on the power lines above the regulations. The SMPS output should have an output regulation of 0.5%. It can be any other value, 1%, 0.2%, but it is quantified. The speed of the DC motor should be controlled over a speed range of 1 to 300 rpm with an accuracy of 0.05%. So, the criteria and specifications essentially provide quantitative goals. Then there are practical constraints. This category of engineering knowledge includes an array of less sharply defined considerations. These are generally derived from experience in practice, and these are considerations that frequently do not lend themselves to theorizing, tabulation, or programming into computer. That is, these are not well articulated or defined precisely. They're more like general heuristics derived from experience in actually doing the job. Examples can be the indicator lamp should be above the switch. The clearance that must be allowed between the physical parts in an equipment for tools and hands to reach different parts. The design should be completed within 2 months. Then the category of design instrumentalities comes in. This is procedural knowledge, including the procedures, ways of thinking, and judgmental skills by which it is done. Examples can be we'll use the top down approach to the design of a product. Phasing of development of a product, structuring of an electronic product, design walkthroughs. Identify all members of the team early on and include every member in the group communications from the outset. This revised Bloom's taxonomy can be produced in the form of a table. On one side, we have the cognitive processes: remember, understand, apply, analyze, evaluate, and create. And on the other side, we have the knowledge categories: factual, conceptual, procedural, and metacognitive. These are the general categories. When we add columns corresponding to the knowledge categories which are specific to engineering, we get a revised Bloom Vincenti taxonomy table, which is same on the cognitive process side, but in the knowledge category side, we add columns of the knowledge categories which are specific to engineering. That means fundamental design principles, criteria and specifications, practical constraints, and design instrumentalities. These are in addition to the four general categories of knowledge: factual, conceptual, procedural, and metacognitive. Most of the engineering courses in most of the curricula in Indian programs uh, are offered at present uh, as, for example, fluid mechanics, thermodynamics, electromagnetic theory, etc., do not address the four categories of engineering knowledge. However, instructor can choose to address some categories of engineering knowledge in his or her engineering science course also. Uh, a 6 by 8 revised Bloom Vincenti taxonomy table can be made applicable to engineering science courses also because of this fact that the instructor may choose to address some categories of engineering knowledge in his or her engineering science course also. So, with that, we come to a quick review of the revised Bloom's taxonomy. As I mentioned in the beginning, this has been covered in detail in our earlier courses like TAIL, NATE, and in the current course, outcome based education and accreditation. So, this is only a quick review in order to establish the prerequisite for the subsequent discussion about the instruction itself. In the next unit, that is W1U4, we will describe some features of how brains learn. Thank you, and we will meet again.